The image landed on newsroom feeds like a postcard. Jupiter, glowing in infrared, banded and bright. Aurora, crowning both poles like a science fiction rendering. Beautiful, safe. The kind of picture that makes people say the word wonder without thinking. But look longer. Look at what the instrument actually captured. Above the equator, Webb resolved a jet of air moving near 480 kilometers per hour, sitting in a stratospheric layer no earlier telescope ever mapped. At the poles, the aurora is glowing hotter than the solar wind is supposed to allow, by a margin no one has cleanly explained. And the Great Red Spot, the storm we have watched since the 17th century, is behaving in ways our best fluid models simply cannot predict. This image was released as a triumph of calibration. It is not that, it is a diagnosis. And what it is diagnosing is us. Wherever you are watching from, whatever hour this is reaching you, sit with this one for a minute. Because the story does not stop at Jupiter. For 40 years, we have told ourselves a version of the outer solar system that sounds settled. Jupiter is the giant. Its stripes are wind bands. Its storm is old and shrinking. Its magnetic field is strong. Its moons are interesting. We built our missions on this picture. We built our textbooks on this picture. We built the confident tone of every planetarium show on this picture. And then the James Webb Space Telescope pointed itself at that same planet in infrared wavelengths no prior observatory could see cleanly. And the picture came back subtly wrong. Not wrong the way a bad exposure is wrong. Wrong the way a diagnosis is wrong. A jet stream we did not know existed. A polar heating budget that does not close. A storm evolving off script. Any one of those in isolation would be a curious footnote. All three on a single planet, on a single instrument run, is something else. It is a signal that the model we trusted was smoother than the reality it was meant to describe. Here is the part that should bother you first. Jupiter is the most heavily instrumented planet in the solar system after Earth. Voyager 1 and 2 flew past it. Galileo orbited it for 8 years. Cassini used it as a slingshot and photographed it on the way. Juno has been circling it since 2016, dipping into its radiation belts on polar passes no earlier mission dared. We have thrown decades of hardware and billions of dollars at understanding this world. And a single new telescope generation, on its very first serious look, is telling us the picture we assembled from all of that was incomplete in ways we did not know to look for. Now think about what that implies for everything we understand less well. The strangest part is not what Webb saw. The strangest part is that Webb saw it changing. And how fast. I want to tell you what the press releases actually said, and what they did not say, because both matter. The official framing was smooth. NASA and the Space Telescope Science Institute described the Jupiter observations as unprecedented views, new insights, refined understanding, standard language, reassuring language. The kind of phrasing you write when you want the public to feel like they are watching progress, not confusion. And to be fair, the images are genuinely beautiful. The auroras look like green fire wrapped around each pole. The rings appear in a wavelength we could not resolve before. That part is real. But read the underlying papers and the vocabulary shifts. Where the press release says insight, the peer-reviewed literature says revising. Where the press release says new detail, the papers say inconsistent with prior models. Where the public communication celebrates a discovery, the technical text quietly notes that a mechanism is not yet identified. This is not deception. It is the ordinary distance between how scientists talk to each other and how institutions talk to the public. But when the gap grows large enough, it stops being translation and starts being softening. Juno has been telling us for years that Jupiter is deeper and more turbulent than we thought. Its microwave radiometer showed weather patterns extending hundreds of kilometers beneath the visible cloud tops. Its gravity mapping revealed that the famous banded jet streams are not surface features. They are structures that reach thousands of kilometers down into the planet, coupled to something we still cannot see. Every mission extension has quietly added complexity to a picture that used to be presented as understood. Webb did not create the contradiction. Webb made it impossible to keep filing under the word refinement. Think about the phrasing for a moment. When an agency says a new observation is refining a model, it means the model was already essentially right, and now it is more precise. When a peer-reviewed paper says an observation is inconsistent with prior models, it means the model was wrong in some direction, and someone has to figure out where. Those are not the same sentence. And in the case of Jupiter, over the past decade, we have been hearing the first sentence in public and reading the second sentence in the literature. That is not a scandal. It is a habit. But habits accumulate. The polar aurora is the clearest example. On Earth, auroras are driven almost entirely by the solar wind slamming into the magnetosphere. On Jupiter, that model has never quite worked. The auroras are too bright, too energetic, too continuous. Something inside the planet's own magnetic and moon-driven system pumps additional energy into them, and Webb resolved that energy in infrared bands earlier telescopes could not see. The polar upper atmosphere is running hotter than solar input predicts, by a margin large enough that it cannot be dismissed as a measurement error, and no one has published a clean, unified explanation for where the extra heat is coming from. To understand why that matters, you have to understand what Jupiter actually is, because almost no one has been told the truth version. Jupiter is not a gas giant in the friendly floating balloon sense the phrase implies. Jupiter is an engine. It radiates roughly 1.5 times more energy into space than it receives from the sun. That extra energy comes from deep inside, from the slow gravitational settling of its interior, from the compression of hydrogen into layers that behave like liquid metal under pressures no laboratory can reproduce. Jupiter has been quietly cooling for 4.5 billion years, and it is still hot enough to power its own weather independently of sunlight. It is closer in physical character to a failed star than to a larger version of Earth. Its magnetic field is the largest coherent structure in the solar system after the sun's own heliosphere. On the day side, Jupiter's magnetosphere extends about 7 million kilometers toward the sun. That is roughly 20 times the distance from the Earth to the moon, wrapped around a single planet, most of it invisible to any human eye. On the night side, it stretches past the orbit of Saturn. If you could see it from Earth, it would appear larger in our sky than the full moon. It has been sitting out there, invisible to us, for the entire history of human evolution. Everyone you have ever loved has lived their whole life inside a solar system whose second largest structure they could not see. Let that sit for a second, because it changes what the word neighbor means. Jupiter is not a distant curiosity we point telescopes at. Jupiter is the second largest gravitational and magnetic presence in the local system. Its influence on the orbits of the inner planets is real, ongoing, and continuous. Every asteroid whose trajectory has been nudged into or out of an Earth-crossing path in the last billion years has been nudged in part by Jupiter. Our planetary defense models depend on tracking that influence accurately, and that tracking depends on how well we understand the object doing the nudging. That magnetic field is not decorative. It accelerates charged particles to velocities that would kill an unshielded human in minutes at the orbit of Io. Every spacecraft we have ever sent close to Jupiter has had to be engineered against radiation totals that would destroy ordinary electronics in hours. Juno carries a titanium vault around its computer that weighs roughly 200 kilograms, and even that vault only extends the mission. It does not save it forever. The moment you cross into Jupiter's magnetic empire, you are inside a hostile environment engineered by physics, not by anything we control. That is the object Webb just looked at. That is the neighbor we share a gravitational system with, not a bigger Earth, not a striped decoration in the outer dark. A rotating, self-heating, radiation-drenched engine with its own weather that runs whether the sun is there or not. And that is exactly the assumption Webb just broke. Here is the weakness hiding inside the giant. The stability of Jupiter's atmosphere, the property that made it modelable in the first place, appears to be less stable than it looked. The equatorial jet Webb resolved was not small. It was moving near 480 kilometers per hour, in a layer of the stratosphere that Hubble and Voyager and Cassini all missed. It was not missed because it was subtle. It was missed because it operates in an infrared band those instruments could not resolve, which raises a colder question. What else is running through Jupiter's upper atmosphere that we still cannot see, because we still do not have the instrument that can see it? The famous belts and zones, the light and dark stripes that define Jupiter's face, have been brightening and darkening over the past several years in patterns that do not match the older cyclical models. Belts that were supposed to fade have brightened. Regions that were supposed to be quiet have turned turbulent. And the Great Red Spot itself, the storm we have been watching for at least 300 years and possibly longer, is shrinking, deepening, and reddening in ways our best fluid dynamic simulations do not predict. None of this means Jupiter is about to do something dramatic. It means our sense of Jupiter's stability was partly a function of our instrument's dullness. What we called steady was often drift we could not measure. Now that we can measure it, the drift is showing up everywhere we look, and that is a fundamentally different situation than the one the textbooks describe. Our models are only as calm as our sensors are dull. Now scale that admission up. There is a reflex, deeply built into how most of us think about weather, to treat Jupiter as Earth writ large. Bigger storms, bigger winds, a bigger version of a hurricane. This intuition is wrong in almost every way that matters, and understanding why is the difference between reading the Webb data as a curiosity and reading it as a warning. A hurricane on Earth is a heat engine powered by warm ocean water and constrained by the fact that it eventually hits land, or cold water, and dies. It has a floor, it has a lifetime, it has an off switch. Jupiter's storms have none of those. There is no ocean to draw from and no land to break against. There is only atmosphere, thousands of kilometers deep, wrapped around a planet spinning once every 9 hours and 55 minutes, heated from within by its own gravitational memory. That is why the Great Red Spot has lived for centuries. That is why Juno's polar images revealed clusters of cyclones locked into stable geometric patterns, arranged in octagons and pentagons that have no analog in any Earth weather system. The equatorial jet Webb found is roughly double the sustained speed of the strongest jet stream on Earth, and that is only what we can resolve at the altitude Webb sees. Below it, in layers we cannot yet reach, the wind speeds may be higher still. Every equation we import from terrestrial meteorology has to be re-derived for Jupiter, because we are not describing a bigger version of our weather. We are describing a different physical regime. Think of it this way. On Earth, a hurricane is a temporary organization of energy inside a mostly stable atmosphere. On Jupiter, the storms are the atmosphere. The bands are storms. The zones are storms. The Great Red Spot is a storm. The polar cyclone clusters are storms. There is no calm background layer that the storms are exceptions to. There is no shoreline anywhere in the entire planet. There is only the storm system, arranged into shapes that persist for centuries, because there is nothing physical for them to dissipate against. And into that system, we are trying to fly precision instruments engineered on models built partly from Earth analogs. And this is where the story starts to widen past Jupiter. Because a large fraction of what we claim to know about exoplanets, especially the gas giants around other stars, is extrapolated from Jovian analogs. If our Jovian model is being revised by a single new telescope, then the confidence with which we describe planets we have never sent a probe to is standing on ground that just moved. The mistake is not only about Jupiter. It is about every world we have been using Jupiter to understand. Now bring it back to what we actually try to do around Jupiter, because the model we've been correcting is the same model our missions were built against. The Galileo probe descended into Jupiter's atmosphere in December 1995. It was engineered to survive as long as possible while transmitting. It lasted about 58 minutes. The atmospheric layers were denser than some models predicted and thinner than others predicted. It measured winds and temperatures nobody had recorded before, and then the pressure crushed it, exactly as intended, because there was no plan for surviving further. That mission was a triumph. It was also a demonstration of how narrow the window is between what we can measure and what will destroy us at Jupiter. Juno has been in orbit since July 2016. Its titanium radiation vault, roughly 200 kilograms of shielding wrapped around its most sensitive electronics, is the reason it has lasted this long. Every polar pass ages it. The mission has been extended repeatedly, and every extension is celebrated as scientific triumph, which it is, and quietly also an acknowledgement that we need more data because our earlier picture was thinner than we admitted. Europa Clipper launched in October 2024, a $5.2 billion mission, 14 years in development. Aimed at Jupiter's icy moon, Europa, it is designed to survive a total ionizing radiation dose of roughly 4 megarods across its planned flybys, a number derived from the radiation environment models we had before Webb. JWST, the European mission to Ganymede, launched in 2023 on a comparable premise, arriving in 2031. Both spacecraft were designed on the older, gentler numbers. Both are now in flight toward an environment we are quietly admitting we underestimated in at least one dimension. A human being at Europa's orbit, unshielded, would receive a lethal radiation dose in under 20 minutes. That is not a headline. That is a floor. That is the reason there is not, and cannot easily be, a crewed mission to the Jovian system in any plan currently on any agency's roadmap. The distinction between a planet we can photograph and a planet we can visit is not a gradient, it is a wall. And the systems built to inch across that wall are being tuned against numbers. Webb is now suggesting we're too optimistic. Imagine the engineering meeting. You are designing a spacecraft that will spend years crossing the solar system, cost your agency billions, and only get one chance to perform. You build it against the best radiation model available at the time. You add margin, you add redundancy, you add shielding, and then, years after your design is frozen and the vehicle is in flight, a new telescope generation looks at the environment your spacecraft is heading toward and tells you the model you built against was optimistic in at least one dimension. There is nothing you can do. The hardware is already in space. The mission is committed. You do what you always do in that situation. You quietly replan the flyby geometry to reduce exposure where you can, you extend your risk assessments, and you say nothing loud about it in public, because saying it loud is how the next mission stops getting funded. The cost of being wrong about a giant is not abstract. Europa Clipper cost roughly $5.25 billion and took 14 years to build. JWST cost about 1.5 billion euros. Voyager 1 and 2 are still transmitting after nearly 50 years, running on assumptions about the outer solar system that we are now revising in real time using instruments those probes could not have imagined. Every model revision that arrives after a mission launches is a strand of that budget that becomes harder to defend, and a future mission that becomes harder to fund. The Apollo guidance computer had 64 kilobytes of memory, and it got humans to the moon and back on a physics model that essentially held. That is what a well-calibrated model looks like. Modern outer planet missions are running on models that Webb is showing were less complete than we treated them. That is a different situation. and it is not one the public conversation is prepared for. Which is exactly why the language around these discoveries stays so careful. Agencies are not lying about Jupiter. That needs to be said plainly, because the alternative is a conspiracy story, and this is not one. NASA scientists publish their revisions. ESA publishes its data. The peer-reviewed literature is available. The problem is not deception. The problem is curation. Public communication is calibrated to maintain funding, to protect mission narratives, to avoid alarming a Congress and a public that already struggle to justify science budgets. So the phrasing gets softened. Insights, not revisions. New views, not contradictions. Refining our understanding, not admitting we were wrong. None of this is dishonest inside the papers. It becomes misleading only in the gap between the paper and the press release, between the caution inside the science and the confidence outside it. The public inherits a register of awe that does not match the register of uncertainty the scientists are actually operating in. And then, every time the picture visibly shifts, the public feels blindsided. Not because they were lied to, but because they were never told, in the emotional tone that would have made them absorb it, that the picture was ever this tentative. You can see the pattern in the way mission extensions are announced. Every extension is presented as a scientific victory, as bonus science, as a windfall. And every extension is also, quietly, an acknowledgement that we still do not have enough data to close the model we started with. Both things are true. Only one gets said out loud. Over years, that asymmetry compounds. The scientific community accumulates a longer and longer list of open questions. The public accumulates a longer and longer sense that everything is going well, and the two lists drift apart until an image like this Webb photograph arrives, and for anyone paying attention to the underlying literature, the gap becomes visible in a single frame. To be clear about what I am not saying exploration should stop. I am not saying scientists are incompetent. I am not saying missions are wasted. I am saying the public model of certainty has been out of sync with the scientific model of certainty. And Webb just made that gap visible in one image. And Jupiter is not the biggest thing this pattern is hiding. Here is where the story reclassifies itself. Jupiter is the best instrumented planet beyond Earth. If a single new telescope generation is forcing us to revise our model of this world, then everything we claim to know about worlds we've never visited is standing on softer ground than the discourse implies. There are roughly 5,900 confirmed exoplanets as of 2025. A large fraction of the gas giants among them have been characterized by comparing their spectra and mass to Jupiter. Our estimates of their atmospheres, their weather, their internal structures, their habitability potential in some cases, all lean on the Jovian analog. If the analog is being revised, so is the extrapolation. Solar system formation models lean even more heavily on Jupiter. The current best account of how the inner solar system got its water, why Mars is small, why the asteroid belt is where it is, and why Earth is where it is, all depend on the assumption that Jupiter migrated inward and then back out during the solar system's first 100 million years. That migration is inferred, not observed. It is a story built to fit the data we have. If the physical model of Jupiter itself is being tightened and retightened, the migration story it supports is being quietly tightened along with it. And on the longest timescales, orbital stability studies, most famously by Jacques Lascar, show that the solar system is not perfectly deterministic. Over billions of years, there is a non-trivial probability of major planetary reordering, and Jupiter, by mass, is the dominant gravitational actor in every one of those calculations. Our year exists because of Jupiter's mass and place. Earth's orbital stability is not an intrinsic property of Earth. It is a downstream consequence of the giant next door. Now think about what that means for the sentences we teach children. Earth's distance from the sun, Earth's tilt, Earth's water, Earth's atmosphere. Every one of those parameters is described in classrooms as if it were a property of Earth alone. In reality, every one of them was shaped and is still stabilized by the gravitational architecture of the system Earth sits inside. Jupiter is a load-bearing element of that architecture, and Webb just told us the load-bearing element is not as fully mapped as we implied. The comforting sentence, "we live in a stable solar system," is a shorter timescale claim than it sounds, and it depends on how well we model the object we just admitted we have been misresolving. That is not a threat. It is a recalibration of confidence, and the difference matters. So when Webb shows us Jupiter differently, it is not adjusting one planet. It is adjusting the reference frame. Which brings us back to the image. That first Webb photograph of Jupiter, the one that ran on newsroom feeds as a triumph of calibration. Look at it now, knowing what you know. The bands are not decoration. They are the visible surface of a storm system whose depth we still cannot cleanly measure. The auroras are not aesthetic. They are the visible edge of an energy budget that does not close. The jet is not a footnote. It is a signal that our best instruments have been dull enough, for long enough, that our sense of Jovian stability was partly an artifact of what we could not see. The image is not a milestone. It is a receipt. It is the bill for 40 years of comfortable extrapolation, coming due at the moment we finally got a sharp enough instrument to read it. The evidence, taken together, is not dramatic on any single line. An unresolved equatorial jet, an auroral heating budget that runs hot, a centuries-old storm evolving off script, missions in flight whose engineering assumed a slightly gentler environment than the one they will encounter, public communication that keeps calling revisions insights. None of these alone is a crisis. Together, they are a pattern. And the pattern says the same thing every layer of the story has said. The confidence intervals on our planetary science have been narrower in public than in the data. And as instruments improve, that gap is going to keep opening, not closing. That is the part almost no one is prepared for. We have been trained culturally to expect that better telescopes will settle old debates. In practice, better telescopes tend to open new ones faster than they close old ones. Hubble did this in the 90s for distant galaxies. Kepler did it in the 2010s for exoplanets. Webb is doing it now in a single image for the planet we thought we knew best in our own system. Every generation of instrument reveals that the previous generation's confidence was partly a function of what it could not see. There is no reason to expect the next generation will be different. There is every reason to expect it will be worse. I want to be careful with the last thing I say, because in this niche, the temptation is always to end loud. I am not going to. This is not a story about panic. Jupiter is not going to do something to Earth in your lifetime. The missions in flight are not going to fail catastrophically the moment they arrive. Scientists are not hiding a secret. The worst-case reading of this evidence is not that we are in danger from Jupiter. The worst-case reading is that we have been operating as a civilization with a level of certainty about the physical universe that our instruments have never quite earned, and that we are only starting now to see how large that gap has been. That is not a comfortable inheritance. It is the more honest one. We are the first generation with instruments sharp enough to see how much of our confidence was extrapolation. The same telescope generation that broke the comfortable picture is also the one that lets us start correcting it. That is a real hope. It is a narrow one. It is only available if we are willing to accept that learning more and being more sure are not the same thing, and that every improvement in resolution is also, quietly, a measurement of how wrong we were allowed to be before it arrived. The people who built Webb knew this. The engineers who designed the mirror alignment, the scientists who wrote the observing programs, the analysts who processed the first Jupiter frames, all of them understood, before the images were public, that a sharper instrument does not just reveal more of the same picture. It reveals which parts of the old picture were guesses in confident language. That is not a failure of the previous generation of astronomers. It is the ordinary rhythm of how science actually moves. What is unusual is not that Webb found anomalies. What is unusual is how quickly and how many, and on a planet we thought we understood. The image is beautiful. That part is true. It is also a receipt, and the bill is longer than the caption said.